Hello there, my name is Alan Barrington. Welcome to my new YouTube channel, which I hope you'll find enjoyable. So this channel is about saving and rebuilding old measuring equipment, machine tools, gauges, and using the tooling that I've saved to help remake bespoke parts for other equipment that I am repairing. I want to mention engineering was never just a career, but it's a deep passion, especially in saving the lives of old and rare equipment from entering the scrapyard, and I give them a nice home here with me. Now, I want to mention this is only an introductory video, so please do expect to see a full overview of each equipment that I have in future videos going forward. So first of all, I'll start off with the measuring machine that you can see behind me. Okay, so this is my SIP MU214B universal measuring machine. So this measuring machine has vernier glass scales on all its axes, on all its cross-slide axes. And they read directly to 50 millionths of an inch, and you can estimate 10 millionths of an inch. And I will mention the scales only move when the slide is actually moving, and they're not tied to any lead screw. So you get no backlash in your readout. It comes with a whole variety of accessories, including work tables, rotary table. You can see the rotary table set up, a whole series of profile heads with different thread profiles. So you can measure a whole variety of thread profiles: Whitworth, metric, unified fine thread, Acme threads, a whole variety. At the moment, a lot of the accessories are in their boxes, but you'll see all this in a future video. I'll get a little bit closer. The rotary table itself reads directly to 10 arc seconds per increment. I have the external comparator, which I use a lot for probing in on external surfaces. This actually reads 1 micron per division. There is a lever indicator as well, but that's in its box at the moment. There also comes an optical flat and a set of lapping plates, small lapping plates. This is actually for, so there is another attachment that comes with this measuring machine. It's in its box at the moment, but you'll see it in a future video. But this attachment has 2 anvils which are used to hold when measuring a tap or a screw plug gauge or a plain plug gauge. And from time to time you need to inspect the 2 anvils for parallelism and flatness, and that's why it comes with the lapping plates and this optical flat. So it's for reconditioning the anvils. I tend to use this measuring machine a lot for mainly for measuring hole patterns, pitch circle diameters or pitch circle radiuses, mostly hole patterns, and sometimes linear dimensions from, so if I'm measuring a center bore to a center bore in a straight line, or even an intersection point to intersection point, or rad center to rad center, or intersection point to rad center. And occasionally I do use the profile heads to inspect various thread pitches and flank angles, mostly of a product thread, occasionally of a screw plug gauge. But as I said, most of the time I use this for measuring hole patterns. It is an absolute brilliant machine to use. It's very, very accurate, and yes, it's fantastic. I will also mention just behind, you can see the test certificates that come with this machine. So you can actually gather the data from the test certificates of each slide, and if you're measuring something that's very, very accurate, you can null the error out. So you can read what the data is and null the error of the readings that you're measuring, if it's something that you're measuring that's very, 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 very precise. Okay, right, so I'm going to I'll just go on to the next measuring instrument. Okay, so this is my Hilger Watts horizontal pattern micro-optic measuring machine. So this machine actually measures internal and external dimensions. I generally use this from time to time with internal and external diameters. At the moment I've got it set up with a set of measuring levers for measuring internal dimensions. So the headstock of this measuring machine, which is this here, this actually has a ground steel cylinder which runs inside the headstock. It has approximately a 4-inch travel, although you can actually expand the overall length much further than that. In fact, you can go up to 8 inches in total. And within the steel cylinder, it's got a set of vernier glass scales. Now, the vernier glass scales are magnified using this projector viewing screen. The vernier glass scales read directly to 50 millionths of an inch, and you can estimate 10 millionths of an inch. So this is your main scale, and the top here is your vernier scale, which you can adjust by adjusting this knob here. Now, effectively, what you've got here, this is a wire which comes from the dashpot around the back of the headstock. So when you do your internal or external measurements, the wire will be hooked up to one of these rods. There's 2 rods actually, one at either end of the steel cylinder. So if you're measuring internal dimensional work, the wire will be hooked up to the lever here and will pull the plunger back this way towards the dashpot. And the same if you're actually measuring external work, you'll take the wire off the lever and switch it round to the opposite side of the cylinder, and where it will push the plunger up to the workpiece for external dimensional work. So basically this is for constant pressure. Now, I believe originally it might have had a very thin steel wire, but I'm not sure. However, when I purchased this measuring machine, it came with a frayed broken string, which I replaced with fishing wire. So this is actually fishing wire. I needed something that was flexible and thin enough so that I could actually hook up to the dash box. It's got a very small, thin hole. So I'm using fishing wire, which I know is very flexible and also strong. And this is what I use for the constant pressure. I do need to sort out a better table for this machine as well. At the moment it's just on a wooden table, just for now. And yes, I will state the dashpot is a cylinder with a dead weight. In this case, the fishing wire is hooked to the dead weight and it's filled with oil, and it's set under tension with a constant pressure of 8 ounces of tension on the wire. So whichever way you hook the wire, whether it's for internal work hooked up to this lever or on the opposite side for external work, you always maintain a constant pressure of 8 ounces when measuring your specimen. So because of this system, you effectively have no backlash or hysteresis in your readouts. It's very, very accurate, very rigid. And of course, having the projector viewing screen makes it much easier on the eye to read the scales, as opposed to a lot of other measuring equipment, optical measuring equipment, where you have to look through the optical eyepiece. So this prevents eye strain. It's very, very accurate, this measuring machine. Very precise, rigid, and extremely easy to use. Normally I'm actually used to using the SIP universal measuring machine, but if there's something I can measure using this, I will, because it's very accurate and very easy to use, especially with the vernier glass scales, which effectively have very, very little expansion, as opposed to metal verniers. And of course the dashpot system for your constant pressure effectively gives you zero hysteresis and backlash in your readouts. So you really can't go wrong with this. This measuring instrument is generally used as a calibration tool for calibrating screw plug gauges, thread ring gauges, plain plugs, and many other types of equipment. But yes, I have to admit, this is absolutely a fantastic measuring machine. I will do another video in the future to show you how I use this measuring machine and how it's used, how it's set up, because there's many other features to this that I haven't actually stated at the moment, but I will go through all of that in full detail in a future video, because it is an absolutely fantastic measuring machine. When I use my SIP universal measuring machine, I generally attach a dial test indicator in order to probe in on a surface. However, you do get the problems with backlash and hysteresis with various types of dial test indicators because of the gearing mechanism. So this is generally why, if I can measure it using this measuring machine, I will, because it's a completely different system. It's a dashpot system via the vernier glass scales, so you don't get that backlash or hysteresis problem. Anyway, I'm going to show you the dashpot around the back of the headstock. So this right here, this is the dashpot with the fishing wire that comes out. The projector viewing screen. At the moment I've got the internal feelers set up, but you can take these off and can fit a pair of these for measuring external surfaces. So it's effectively interchangeable. This is the main measuring cylinder. I'm just pushing along through the headstock. And on the top is the vernier scale controlled by the milled knob. But anyway, I will do another video on this where you can see me actually use it and how it's used. It's yes, and it's just absolutely fantastic. And there's many other features which I haven't explained yet, and I will do in the next video. Also, I will mention I'll need to clean a bit of this. It's a bit of a paint stain on the frame. I got this machine. It's from a lady that I know, and in fact it was her. It belonged to her father. Also, just as a side note, the main work table can be elevated with this hand wheel. This locks the height, so you elevate your table to the correct height that you're looking for, and then you can lock it off. This knob here allows you to move the work table forward and backwards, and this knob here allows you to tilt the work table for squareness. It's very, very useful. And this knob here, this allows you to oscillate the table, so you can really square your part up in order to gain the most correct reading that you're looking for. So you can really square your part up for squareness and straightness. And because you've got the constant pressure on your specimen via the dashpot, you'll pick it up on your glass vernier scales. This is my ongoing project. So this is a mini lathe which has been re-engineered by myself It's far from complete. So it's, as I said, it's an ongoing project, and I'm converting this into an ultra precision single point diamond turning lathe. I'll just go through the basics of what I've actually done. I have lapped the saddle and hand scraped the main bedway of the lathe. Besides the scraped bedway, I have assembled and fitted the blockhead air bearing spindle. This is actually a rebuilt air bearing spindle, which I purchased a few years ago, and it was in a scrap state. So it was in a non-working state. It was completely seized up. That's, of course, with the air going through and the rotor lock off. It was completely seized up, so I rebuilt that, and at the moment it's just temporarily set up on the bedway with a temporary mounting block. This is just so I can set up and adjust the height. And I purchased a rubber flexible coupling, and I made the plates from aluminium and steel to help join the spindle to the lathe headstock via the rubber flexible coupling. And I'm just testing that through. Whether I'll stick with that, I don't know. I'm just going through the trials at the moment with the coupling. But I will be making a different mounting block at the bottom. And I've got a new tool post. This is a multi-fix Swiss tool post. This was actually a fantastic tool post. It's been very, very good. This is to stay. The compound slide will be taken off. I won't be scrapping the compound slide, but I don't use it that often at all. But I will be scraping the cross slide. This has not been done yet. So I need to scrape the cross slide for straightness and squareness with reference to the spindle face. And I do have a T-slotted iron which I need to remachine and scrape, that I will be fitting on top of the cross slide, and then the tool post will be fitted on top of that. I will save the compound slide with a protractor scale for when I need to use it in the future. I also have a new hand wheel to fit as well. So at the moment, what I want to do is to make this a little bit more rigid, is I'm thinking about, I will be fitting a sealed bearing in the apron and machining another shaft so it'll fit this hand wheel. This is a steel hand wheel. It's much more solid and heavy, and I want the apron to be a little bit more rigid to the frame. So I will be boring the hole out in here and fitting an actual bearing, and will be machining a new shaft so it'll fit the hand wheel and of course the gear behind as well. And also I will make another tailstock as well, because the existing tailstock is very difficult to use, especially for centralizing the tailstock with a center. So, and also I would like to build another revolving center, possibly a self-acting air-bearing revolving center. I don't know. I'll see how it goes. But as I said, there's lots of work to be done. This is the main project that I'm working on. So there's going to be lots of videos about this going forward, because at the end of the day, I want to use this machine tool, this single point diamond turning machine, to rebuild a lot of my measuring equipment which I've been repairing. And there's bespoke parts I need to machine, and they need to be accurate. So effectively, as far as machine tools are concerned, this is my phase one of the ultra precision lathe. The lathe headstock itself, I haven't changed the bearings on that yet, but I will do. At the moment it's got the original ball bearings in the headstock, but I'm going to change it to possibly to the taper roller bearings. Or maybe the angular contact, but I'm thinking more on the lines of the taper roller bearings in the headstock. So this lathe won't be just solely used with the spindle. The spindle is just for finishing, by the way, to ultra precision. But I can take the spindle off and rough out all the machining with just the lathe headstock. So the idea is to do all the roughing out on the lathe headstock, then mount the spindle back on with the coupling with ease, and then mount the roughed out piece onto the spindle, and then finish it on the spindle to the tight tolerances. So I've got to make an adapter plate as well for the spindle, so that it will enable me to fit a 3-jaw chuck to it, and also I need to make a face plate as well. So I've managed to find some material, some cast iron for the adapter plate for the chuck, and also for the face plate as well. So what I have here, this is called an Rolt comparator. As you see, this was actually used for calibrating slip gauges, gauge blocks, and it's known as the Rolt millionth slip gauge comparator. This needs a full overhaul and repair. There's a couple of things missing on it. There's a mirror and even a set of scales as well. So I'll be on the hunt for looking at parts that go with this comparator, and possibly even remaking bespoke parts using my once is complete single point diamond turning lathe to help rebuild this comparator. So I bought this just over a year ago from a very nice lady that I know, whose father was an engineer. Okay, so right behind my Rolt comparator, I have my More Precision Tools rotary table. So this is a precision rotary table. It's tucked in its box at the moment, so I won't be able to get it out just yet, but you will see this in future videos. Okay. And then just above my rotary table, this is my SIP accessories box. This is where I keep all the accessories, clamps, and all the other scopes for the universal measuring machine. And on top here, I've got my my 2 Carl Zeiss optical parallels. This is a Boxford comparator. This reads 1/10,000th of an inch per increment comparator. And just underneath is my cast iron lapping plate. And behind the cast iron lapping plate, I've got this is a homemade copper lapping plate. And some toolmaker's buttons. And this is a bench micrometer stand behind. And then right in front here, I have my Johansson Mikrokator. So this Johansson Mikrokator, this one reads 0.1 microns per division, or 100 nanometers per division. I use this a lot for, in fact, especially I've been using this a lot on my mini lathe and a few other stuff as well. So this is my Raglan vertical milling machine. The headstock of this milling machine, the spine, and the base is one casting made of aluminium. The work table is made from iron. You don't have a quill that runs up and down for the Z-axis with this machine. Instead, you've got the whole work table elevates, and you can, so it's controlled by this hand wheel here. This is what controls the Z-axis by moving the whole table up and down. And you can wind the hand wheel by 5/10,000ths of an inch per increment. And the Y-axis cross slide is 1 thou per increment, and the X-axis is also 1 thou per increment. And it has a Morse taper 2 spindle fitting. This is made in Nottingham, this Raglan vertical milling machine. Very rigid. This here is the spindle speed control lever. You only operate this when the motor is running. And these are your spindle speed settings. This is the drawbar. At the moment I've got a sit boring head set up. This is another sit boring head. These are micro adjustable sit boring heads with a vernier scale. So these can be adjusted by 2/10,000ths of an inch per increment. These ones in particular anyway. And they're obviously Morse taper 2 fitting as well. The boring tool insert is inside a box at the moment, so I've taken that out. And this is my ER32 collet holder and the spanner, and collets, drill bits, small end mills, and I use this for drilling, boring, and a little bit of milling. It's a small milling machine, but it's very rigid. Okay, so this is my Hilger Watts microptic vertical pattern measuring machine, and it's based on glass scales. So it's got a set of vernier glass scales inside this column here. So this column runs inside the head casting. It's got a set of 2 bull races inside the head casting, and the vernier glass scales through the optical eyepiece, they read directly to 50 millionths of an inch per division, and you can estimate with this one 10 millionths of an inch. And it's based on, so the actual column itself is attached via a steel pulley wire with a pulley on the top. You can probably just see it if I lift it up a little bit. There's the pulley. And inside the spine of the measuring machine is a counterweight. So effectively it's a type of dashpot system filled with oil. Unfortunately, there's a lot of oil that's leaked out of this measuring machine, so it's something I need to sort out. And also there's a kink in the steel wire, because by right the plunger should come down under its own momentum because of the counterweight set at a constant pressure, but unfortunately it doesn't do that. This here adjusts your sets your height so you don't go all the way down. It's like a safety pin, so it prevents the column from going straight down and hitting the anvil as I said, there's a kink in the wire. The anvil itself, it's actually loose. It's not fitted. Because I took this off previously. This was actually very, very rusty, and I actually removed a huge bulk of the rust previously, a few months ago, and I did actually lap it as well. So that's why it does look shiny, but it's not complete. I'll show you what I mean. So this is the anvil. As you can see, the surface is heavily pitted due to the rust from previously. So what I intend to do later on, because at the moment I've got other projects on the go, so I will come to this in the future. But what I will do is surface grind the surface and then re-lap it. So that'll be a future project. Plus I'll sort out the wire, as I said, and the counterweight system. So that's the anvil. This knob here, what this does is it allows you to elevate the anvil for fine adjustment. That's what this does. That's the locking system, locks in place. You have to set the, obviously at the moment it's only on a wooden box, but you need to get, once it's rebuilt, you set this on a surface table, level it out. So you've got three pins here which will allow you to level the whole measuring machine. And there's a small little spirit bubble. There's a small little spirit bubble just behind the anvil, and you adjust the adjusters to level it all out, and then you can proceed to use it. Well, that's it for today. I hope you've enjoyed watching this video. If you have, please hit that like button. By all means, do leave a comment as well, and don't forget to subscribe to my channel. I'll be most appreciated. And I'll see you in the next video.